Okay, so let's talk about the second part of today's class, which is about querying in MongoDB. So last time we talked about, earlier we talked about how to design document structure in MongoDB. And let's assume that we have documents and data stored in our collection, and then how we can actually design a query. So that will be what we are going to talk in this part of the class. So before we actually talk about the query in MongoDB, we have to first prepare some data set. So I prepared some sample data sets on the Blackboard. So we can go to the Blackboard and we can download this and we can put it on our MongoDB first. So there are steps here, but let me go through together. So basically, if you go to the Blackboard, there are two data sets here. Gyps nyil.js and gyps txca.js. So both are like a JavaScript extension. So in each of this JS file, you can right click on it. Then there will be multiple options, and you will have this option called the save linked content as. So basically save this content as, like using different file name. So you can choose that. So choose right click on the each JS file and choose save linked content as and save it on your PC. So in my case, I'll save it on the desktop. So I already saved it here, downloaded gyps nyil.js file and gyps txca.js file. So download these two JS files on your PC first. So once you finish downloading these two files, basically you can go to the Robo3T and right click on the test database and click open share. So what we want to do is that we are going to populate this data into the test database. So right click on the test database and click open share so that we can actually store this data into the test database server. And then once you open this share, on the top here there's this this icon here, the open file, basically here, this one. So if you click this open folder, open file icon, you can choose the file. So basically on desktop, I downloaded these two JS files. So open the first one first, gyps nyil.js. Open this. Then you will see this script. So basically what we do is that I already prepared this data, multiple documents, and I want to add this into city collection. So open this gyps nyil.js and click the play icon on the top here. So click this, then it will be performed. And if I wait a little bit, it says that it's done, and it says that 2,834 elements are kinda added correctly. Do the same thing for another file. So close this, right click on the test database, open share, and click open file and open gyps txca.js. And click play icon on the top to populate 3,200 documents into your database. And close this. After you do this, you can right click on the test database, and if you click refresh, you will see that there is a CD collection created here. So to see what's here, I can right click on the CD collection and I can choose view documents, or I can open share on the test database and I can type something like database.cd collection and find, or I can use find one. So if I use find one, it will retrieve the first document in the collection. And then if I click play icon, basically it will retrieve that the first document in the CD collection is this. Basically it has this kind of information. So this step is all on the slide, so you can follow the steps written here. So we download two JS file and open this file in the Robust3T under test database, and if we perform it, you will have a CD collection created in your test database, and inside the CD collection a lot of documents will be added. So make sure that you finish this step first before you go for the query part, because we are going to use the data here. So basically, what is data about? Let me talk a little bit about what's the data. So these two JavaScript files basically contain information about the zip code. So it contains information about the US zip code across 4 major cities, which is New York, Illinois, Texas, California. And each file, each document will contain this information. So basically, this is the first document inside the collection, and the information contained in each document is this. It has an ID field, so ID field represents the zip code. So 10001 means that zip code is 10001, and it also has a CD field, which has the name of the city, the New York. It also has a location with the longitude and latitude. So the GPS location is here. And there's also a population field, which contains how many people live in this zip code area. And then the last information is the state field. So it has NY, IL, TX, or CA information. So which state this zip code belongs to. So basically it's the zip code information containing how many people live in that zip code. So query is a process of filtering documents that satisfy certain criteria. So we know that because we also covered query in the relational database. And in MongoDB, query is used across in many different operations and many different functions. So the main places where query is used in MongoDB is here, the find function. You want to find a certain document that match the query. Then in the find operation, basically in the read operation, we specify the query here. Also, it's used in the update function. So earlier we told that in the update function we have 3 parts: query, update, option. So the first part is the query. So we can also use query there in the update function. And also in the remove function we can specify query. When we want to delete a certain document that satisfy a certain condition, then we can specify query in the remove function. So this part actually about studying the query. This will be more like studying a programming language in some sense. So I basically for this part, and on Saturday when we talk about update query and aggregation, I'll go through many different operations we can utilize in the MongoDB. So let's try this by step-by-step hands-on exercise. So if you have a laptop, you can also try there. So the first one is this. The basic structure of a query is this. When you specify query, basically we specify query following the document structure too. So we will have an open bracket and close bracket, and inside the bracket we specify the condition or criteria. So if we want to find the entire document, then we can simply specify open bracket, close bracket, and inside nothing, like this. So in the relational database, when we want to select entire records, we use this star sign. It's similar here. In the MongoDB, if we want to retrieve the entire document in the CD collection, we can use this code basically. So we specify the DB database .cd, the collection name, which is cd, and find the function, and inside here we can specify the query. So in this case, it will be just this. If we want to specify retrieve entire document. So for example, here, so the CD collection is under the test database. So right click on the test database and click open share, and here I can specify the query. So database dot CD collection. From the CD collection, I want to retrieve the entire document, then open bracket, close bracket, and close parenthesis. And then if I click play icon, it will retrieve the entire document from the CD collection like this. And if we want to retrieve all documents which match a certain condition, then you can specify inside this bracket. So you can specify a key and value that you want to be matched. So you can specify like this, key, colon, value, like this. So for example, if we want to find all the zip codes in the state NY, then you can specify something like this. Inside the bracket, we can specify the state should be matched with NY, something like this. So for comparison, to help you understanding, I also put the similar code in the relational database here, so you can compare this. So basically, I can type this. So in the MongoDB, if I type state field should be matched with NY, and if I click the play icon, then I see that all the documents returned here, the state field is NY. So that's what you can see here. So basically, that's how you can specify the condition in the find function, basically. So you can also specify multiple condition. So it's simple. So basically, if you want to specify multiple condition, you can use the first key and the value that should be matched, and you can use the comma, and you can specify the second condition like this, and you can specify more condition with the commas like this. So when you use a comma, basically it will be something like AND. So these two conditions should be matched together. So in this example, if you want to find all the zip codes only when they are in the state NY and also located in the city named medicine, then you can design something like this. Something like this. So if I copy this, and go to the MongoDB and put it here. And one thing is that, so if I copy it from the Microsoft Word or Microsoft PowerPoint, this quotation sign will be changed. So we have to use the original quotation sign like this. So if I perform this, then I see that there is only one document returned. So there is only one zip code that belongs to city medicine in the state NY, like this. So basically that's a simple way of specifying multiple conditions in the find query. So also when you design the query, you can specify the returning keys. So what it means is something like this. So if you just design the query, then the entire document will be returned as a result. But you may not need the entire document as a result. You may want to know a specific information from the document. Then you can specify that too. So to use the returning rule, you can use the find function, and you can specify the query. And after that, you can use comma, and you can specify the return rules. So in the return rules, you can specify which key should be returned. So like a key, and if you specify 1, that information will be returned. And if you don't want to see certain information, you can specify the key, and you can specify 0. So for example, the unique ID information will be always returned, but if you don't want to see, you can specify ID and 0 like this. So in this example here, we want to find the population of CD medicine in the state NY, then we can design something like this. So first of all, we can design the query, which is the same as what we designed earlier. So the state should be NY, and the CD should be medicine, and finish this query. So that's the query part, and specify the comma, and then in the next line specify the return rule. So return rule is that I want to know population information only. So the population field should be returned. However, I don't want to see ID field. Then ID field I can put 0 in the returning rule like this. So here, the first line here is the query. So basically, same as earlier. Find all document in state NY, which has a name, CD name medicine. And here, I use comma, and then I specify the return rule. Population, I want to see. ID, I don't want to see. So specify like this. So basically this part, copy it, and go to the MongoDB, and here, if I add it here, it will be like this. And if I perform this query, you will see the result. So one document is returned with only population. So there is no other field. And the population is 1472 like this. So that's how you can specify the returning key. Okay. So if you miss some parts, don't worry, I'll share this document with the solution later on the Blackboard. So if you miss some parts, don't worry too much. Another operator you can utilize is a comparison operator. So you can use a comparison operator with the number field together. So rule for using comparison operator is this. So you specify the key, and here in the value, you use another bracket like this. And here you specify comparison operator, and you specify the value. The comparison operator you can utilize in MongoDB are these 6 things. So equal, not equal, greater than, less than, and something like that. So in this case, if we want to, let's try some example here. So if we want to find all the zip code with the population more than 100,000, then we can try this. So first of all, the field we want to compare, we have to specify that first. So we want to compare population. So specify population. And then we specify condition operator. So open bracket again. And the comparison operator we want to use is more than. So greater than. So which is $GT and colon. And it should be greater than 100,000. So we specify the value 100,000 and close the bracket, and then close the entire bracket. So basically here the thing is this. So inside this inner bracket we specify condition greater than 100,000 that should be applied into population field. So we specify that like this. So copy this, and if I use this code in the MongoDB, then the results will be like this. So basically there are 4 zip codes which has a population more than 100,000. So that's what we can know from this code. So another comparison operator we can utilize is in operator. So you want to specify that a certain value of the field should match one of the certain options. Then you can use the in operator, and you can list those values inside following the list format like this. So it's better to look at the example here. So we want to find all the zip codes with the population of 3,593 or 26,365. So basically population should be either this or this. Then we can use the in operator in this case. So for example, for this one, we can specify like this. We are comparing the population, so specify the population, and then we specify the comparison operator. In this case, it is in operator. And the option that should be matched, we put it in the list. So the first option should be this or this. Like this. Basically, this specifies that the value of the population should be either this or this. So you can copy this. And here, if I try, you can see that there are two documents returned. One has a population 3,593. The other one has a population of the second option we specified here in the in operator, like this. Okay, so that's it. And another comparison operator is similar to this, but also there's this operator, not in. So we want to find some documents with a value that doesn't match with one of the options we specify, then we can use a not in operator. So for this one, if we want to find the zip code in neither NY nor CA, then we can use this operator. So here basically, in this case, we are comparing state, and state should be not in NY nor CA. Then we can that's it. So we can copy this and test it here. And then we can see the results. So there are a lot of documents returned, but you can see that the state is not NY nor CA in this case. So that's the not in operator. And another operator we can utilize is also logical operator. So in the relational database, when we design the SQL, we utilize the multiple logical operator like AND operator, OR operator, NOT operator. The same thing we can utilize here too. So there's AND operator. So if you use AND operator, basically you can specify AND operator here first before you specify any field. And then inside here, you can specify multiple query as a list format. So when you want to specify multiple query, and if you want to use the AND operator, then you can use it something like this. So in this case, if we want to find all the zip codes when they are in the state NY and located in the city named Madison, earlier we designed the same query simply by using the comma, but we can also use the AND operator in this case. So if we use AND operator, then it will be something like this. So we specify AND, and then you can list multiple queries here. So something like this. Oh, actually, yeah, something like this. Okay, so if I specify like this, basically I have two queries here. The first query here is state ny, so it should be the state should be the ny. Second query is the city should be the medicine, and I want to apply these two queries. So I use the list format here, open bracket, close bracket here. So these two query, list of these queries should be combined by AND operator. So these two queries should be matched together to return the result. So that's what I try to do from this query. So if I copy this and perform, basically you will see the similar results as we saw earlier. So if I perform this query, then yeah, I see one document which is in city medicine in the state ny. So that's the AND operator. And there's also OR operator. So if you want to find the documents that match one of the multiple conditions, then you can also use OR operator, similar to what you did in the SQL. So the syntax is the same. You can use the OR operator and you can list multiple queries using the list format. So let's show this example quickly. So if we want to find all the zip codes which are in Medicine NY or Berkeley CA, then we can design this using the OR operator like this. Like this. So I'll skip trying this in the MongoDB. You can try this later. So basically, I use the OR operator, and similarly as what we did earlier, inside the list, I specify first query and second query like this. Then, as a result, any document that match one of these two conditions will be returned. The next one is the NOT operator. So it's the same. Basically, also we can specify in this case we specify the key first, the field first. And if the field doesn't match the operator expression you specify here, then you can use the NOT operator. So basically, when you want to find the key values not matching any other operator expression, then you can see the results returned. So if you want to find all the zip codes with a population not less than 100,000, you can design the query using the NOT operator. So this one, basically, we are comparing the population. So we specify the population field first, and then not less than 100,000. So we specify the NOT operator. And then we can specify the condition. The condition operator should be less than. So less than 100,000, like this. So we can try this. So copy this. And if I try this in the MongoDB, it will show the results of those zip code with the population not less than 100,000. So not less than 100,000 means that greater than or equal to 100,000. So that's the NOT operator. But there's something you have to be careful when you use the NOT operator. So which I detail more in the next slide. So when we think logically, we will think that to find all the zip codes with a population not less than 100,000, we may think that these two queries are actually the same. So not less than 100,000 is, in another way, greater than or equal to 100,000. So instead of this, you may think that we may use this. But the way these two queries work are actually different in the MongoDB. So we can think about this. So earlier, what I mentioned is that in the MongoDB, the data modeling is flexible. So every document may have a different structure. So let's just say that we have another document like this. We have zip code 9999, CD is just test, and state is NA. And let's say that this document doesn't have any population field. Then what will happen? So we can try this. So let me add this first. Let me copy this. And let me sample data into our CD collection first by performing a play button. Then this data is added now into a CD collection. So the problem of this data is that we don't have any population information here. So population field doesn't exist. Then logically, we think that these two queries should give the same result. But let's just see what happens when we perform this. Okay, so I copied both of them, and if I click the play icon, so these are the results basically. So you can notice one thing is different here, right? So on the first result, when we use the population greater than or equal to 100,000, the 4 documents are returned correctly. And when we use the second query, not less than 100,000, 5 documents are returned. So basically the last document we just added, which doesn't have any population field, is returned as the result of this second query when we use not operator. So what does the MongoDB is doing is the inversing basically. So basically MongoDB processes this part first. So they find all the documents with the population less than 100,000. And then because of the not operator, it inverts the results in a collection. So basically, MongoDB from the entire collection, it will remove all these documents they find, and they will return the results. So basically, this document we just added, it doesn't have any population field. So when the MongoDB performed the first part, this document was not included. And when we use a not operator, it does an inverse collection. So this document is now included in the result. So that's something you have to be careful when you use the not operator in the MongoDB. Okay, so another like a helpful operator you can utilize in this kind of situation is the exists operator. So if you want to specify that whether a certain field exists or not, you can utilize exists operator. So this second query, population not less than 100,000, if we want to make this query to the same thing as the first one, we can utilize this exists operator. So in this case, we can design the query like this. So let me try this first to make sure that whether it works correctly. Okay, so if I use this query, then yeah, it returns 4 documents correctly. So basically, here I'm specifying the 2 conditions basically. for the population, it should be not less than 100,000, but also population should exist. That's what I specify here. Yeah, so that's how you can, that's basically one example of utilizing exist operator. So using exist operator, if you want to filter those documents that doesn't have a certain field, you can do that. So that's the main thing this operator can do for you. Okay, so let's there's one exercise. Find all the zip codes with the population between 80,000 and 82,000. So we can make this query basically using AND operator or also without using AND operator. For the time, I will just show you the solution. So you can try this later. So basically to design this, we can use the, we can start from db.cd find function, and inside the find function we can specify the query. First of all, we are comparing the population, so we can use the population, and we have to compare this, so we can use the conditional operator here. And the conditional operator we can utilize is this. So first of all, it should be greater than 80,000. So greater than or equal to 80,000. And if we design a query without AND operator, we can specify one more condition here, less than equal to 82,000, like this. So that's the first way. Then this query will basically compare the value in the population of each document, and it will check whether it's greater than or equal to 80,000, and at the same time it should be less than or equal to 82,000. Another way to design the same query can be this. So instead of this, we can also utilize the AND operator. Basically it will do the same thing. So we use the AND operator, and we list two conditions inside here. The first condition is population should be greater than or equal to 80,000. And the second condition should be population should be less than or equal to 82,000, like this. So I will not try this. You can try this later. Basically, these two queries will do the same thing and will give the same results. Okay, so I skip this part for now due to the time. You can try this later. I upload this on the Blackboard. So it's a simple exercise. So next one, let me talk about the list operation. So different from the relational database, so in this case in MongoDB, the data type they support is more flexible. So one of the data type they support and quite useful one is the list. So list data type is used quite a lot and frequently in the MongoDB because sometimes we have a list of embedded documents or list have some elements, something like that. So in this case, let's prepare this data first. So what I want to do is this. So I prepared the sample code here. Basically what I'm doing is that I create the food collection in the MongoDB, and inside the food collection I add 3 documents. First document name is Tom, and he has 3 fruit. So fruit is a list of elements. So Tom has apple, banana, peach, and the second document is about Jane. Jane has apple, kiwi, orange. Third is Bob. Bob has cherry, banana, apple, like this. So if I copy this and if I perform this in the MongoDB, then 3 documents will be added like this. And if I right click on the test database and if I click refresh, you will see that there is a food collection created. So if I right click and if I click view documents, I can see that 3 documents are added into the food collection. For Tom, Jane, and Bob, we have a list of fruits for each person like this. So we prepared this sample data, and let's just see what happens if we perform these queries here. So the first query I prepared is this. I want to find the people who has a banana. Then we can use this query. So if we specify fruit here, and fruit, the data type is a list of element. And if we specify banana, basically this banana will be searched inside this list. So Tom has banana, Bob has banana. So these 2 persons documents will be returned as a result. So let's just see whether that works. So copy this, and if I perform this, then as I told you, Tom and Bob's documents are returned because Tom has a banana, Bob also has a banana. So basically for the list operation, if you specify one element here on the list field, this element will be searched over the list to find a match. What if you want to find multiple fruits? So what if you try this? So if you try, if you specify fruit field and if you specify a list of elements like this, banana and apple, then let's see what happens. So if you try this query in the MongoDB, then nothing will be returned actually. Because of this, if you specify a list as a value in a query, basically the MongoDB will try to do entire match. So it will try to find whether the fruit is exactly this list. But currently everyone has 3 elements in the list. So there is no exact match of this list among these data. So nothing will be returned in this case. So so here if you want to find a person, so I didn't prepare for the solution here, but if you want to find a person who has a banana and apple together, basically you have to use this and you have to utilize it together with the AND operator. So you can use the AND operator and you can specify 2 conditions, fruit banana and fruit apple like this. So this is something you have to be careful when you use MongoDB and when you perform the operation over the list data type. And another operator you can utilize over the list data type is the size operator. So if you use the size operator, it will find the documents with a certain number of elements in a list. So if you want to, so basically size operator you can utilize like this. You can specify the key field and you can use the size operator and you can specify the number. So if you want to find the people who has 3 fruits, basically you can do this. First of all, the fruit field should be size operator, size of 3, like this. So if I copy this, if I perform here, then it will return all the documents because everyone has 3 fruits in this case. One thing many people are curious is about whether we can use a comparison operator together with the size operator. So for example, what if we want to find people with less than 3 fruits or something like that? But however, in the MongoDB, they don't support this functionality yet. So MongoDB, it's being updated very regularly, but it's not being supported yet. So we cannot use comparison operator together with the size operator at this moment. So what should we do? If you want to utilize a comparison operator together with the size of a list, then one way is that we can add a size field inside the document, and we can update this size field based on the number of fruits or number of elements in the list. And then using that field in the document, you can use the comparison operator. So it's a little bit complex, but that's what we can do if we have to utilize comparison operator with the size of a list. Okay, the next one is this. So in the list data type, we have a multiple elements, and we want to know a certain location of element in the list is a certain value. Then we can use this key.index format. So basically, when we want to find the document, when a certain location of element is a certain value, then we can use this format. So for this format, you have to use the quotation mark here, and inside the quotation mark, you specify the field and dot and index. Index is basically number which represents the location in the list, and then specify value. So for example, in this case, in this example, we want to find the person whose second fruit is banana. Then we can specify like this. The fruit field, second fruit. So in this case, I put 1 because in the programming language, when we use the list data type, the first element starts from 0 location. So the second fruit should be first location. And it should be banana, like this. So if I try this in MongoDB, it will give you 2 results basically, and both of them, the second fruit is banana, as you see here. So this is another list operation you can use over the list data type. Okay. There's also this operator, slice operator. So if you earlier we talked about the returning rule, so you can specify a certain field to be returned or not. This is similar. In this case, you can specify a certain part of a list to be returned as an example, as a result of your query. So if you don't want to see entire list as a result, you can utilize this function. So for example, after in the find function, after you specify query, you can specify the returning rule here. So you specify the field you want to see as a result, and here you can specify the slice operator, and you can specify the number. If the number is positive, basically, if for example if you put 10, first 10 elements in the list will be returned. If you put the negative number, last those number of elements will be returned as a result. If you want to return the middle part of the list, you can specify 2 numbers in the list format like this. The first number will be skipped, and the second number will represent how many elements to be returned. So if you specify 5 and 3 like this, first 5 elements in the list will be skipped, and the next 3 elements in the list will be returned. So you can check this and you can try more. I just provide you a simple example here. So for example, if we want to find the first fruit of all the people, then we can design something like this. First of all, we have to specify query. So we want to find first fruit of all the people. So all the people, so query is simply this. And the returning rule we can specify here. So what we want to see as a result, which is fruit. We want to see fruit as a result. However, we don't want to see the entire fruit list. We can only want to see the first fruit like this. So this slice operator is actually quite used frequently in the real world because sometimes we want to see the recent 5 activity or recent 3 activity depending on situation. Then we can use a slice operator in that situation. So copy this and try this in the MongoDB. Then I can see the result like this. So for each document, if I look at the fruit list, only the first element is returned like this. So that's how you can check the result of this query. So when you have like a list data type in MongoDB, and when we are trying to make a query to filter some data there, you have to be a little bit careful about it, because how the MongoDB query is, it might be a little bit different from what you would expect. So the best way to test this is actually by showing the example. So let me actually try this. So here I prepared the simple code here. So basically what I'm doing from this code, part of this code is that I am preparing this database called testx, and basically I'm gonna insert 3 documents. So first document is x equal to 5, second document is x is 15, and the third document has also x field, and in this case we have a list of 2 values, 5 and 25 inside the list. So the last one is the list data type. So let me perform these 3 lines of code. Let me copy this and let me go to the MongoDB here and right click on the test database and open shell and copy these 3 lines of code here, and let me perform this. Okay, then it's performed correctly. So 3 records are added. So if I refresh my test database, I see that there is a testx collection created. So if I right click on the testx collection and if I click view documents, then basically I'll be able to see there are 3 documents added into this testx collection. The first document has x with value 5, second document has x with value 15, the last document has x as a list with 2 elements, and first element is 5, second element is 25. So these 2 values are in the list. So let's say that we designed this query as you see here. So basically we use the find function here and we designed this query, and this query is doing searching basically over x. So every document has an x field in this case inside the testx collection, and we want to filter documents when this x value is greater than 10 at the same time less than 20. So we want to find document with x greater than 10 and less than 20. Then the first document, x equal to 5, it will not be included in the result because it's smaller than 10, right? So it doesn't satisfy the first condition. The second document, 15, it will be returned because it's between 10 and 20. How about the last document, which has a list of 5 and 25? Will this be returned as a result of this query or not? So we can test it actually. So I can copy this part of the query and I can go to the I can make a new shell for the test database, and here I can type this query. So basically on testx collection I want to find document with variable x greater than 10, less than 20. And if I perform this query, you will see that 2 documents are returned actually. The first document which we expect, x equal to 15, which is between 10 and 20. Second document has a list of 2 value, 5 and 25, but this is also returned as a result of this query. So let me tell you why this is happening. So currently there are 2 conditions, and this will be applied into x. So the first condition is greater than 10. So if you look at this list, there is one value, 25, greater than 10. So this one is satisfied. So basically when you use query on the list data type, each query will be applied on each element inside the list, and if at least one element satisfies that query, that condition, it will say yes. So greater than 10, the first condition is satisfied because this list contains the value 25, which is bigger than 10. And the second condition is less than 20. It's also satisfied because this list has a data 5. which is smaller than 20. So as a result of this query, this document will be returned. Even though each number is not between this, when you look at the whole number, there is at least one number which satisfies each condition. So that's how MongoDB processes a query over the list, and that's why this document is returned as a result of this query. So this is what you can do. So if you want to make a condition, and if you want to utilize those conditions to be applied in the each of element in the list separately, then you can use the lm match. So basically, if you use the lm match, each element in the list will be checked against multiple conditions you specify. So in this case, if you try this code, you will see that the last document is not returned. So if I try this, copy it, and if I put it here, and if I perform this query, then you will see that the last document is not returned. But the problem is that also the second document is not returned, which has x as 15. The reason is this. This lm match operator only applies to the list. So basically lm match is taking each element from the list. But the second document here was x equal to 15. So this is not the list data type. So lm match, if you use the lm match operator, it will ignore this because it's not the list data type. So that's something you have to be careful. So if you use lm match, you can utilize this condition on each element, but it will only use this condition on the list data type. So the question is this: what if we want to make this x equal to 15 to be returned as a part of a result? Then you have to design query a little bit more complex. So again, let's say that we have these three documents as we prepared earlier, and we want to correctly retrieve documents with the condition x is bigger than 10, and at the same time x should be smaller than 20. And what we want is that only the second document to be returned as a result. Then in this case, you can design a query like this. So it's a little bit longer, so let me just type first, and then let me explain how this works. Okay, so this will be the basically code to solve this problem. So it's quite simple, right? So there are two things first here. So if you look at this carefully, actually it's not that difficult. So there are two things I do here. The first part is here and the second part is here. So I use the OR operator here. So basically at least one of these two conditions are satisfied. The document will be returned as a result of this query. And the first part here, basically this part is if I put some explanation here, basically the first part is about when x is value. So I consider two cases basically. So first case is when x is value, and the second case is when x is a list. So there are two possibilities in this case. So x can be value sometimes, x can be list sometimes. So if x is value, how do I check? I check by using this. So earlier, so last time we talked about the indexing in the list. So basically, if you remember, we talked about this format. So if you specify the field dot and if you specify the index number, basically that number element, so if you specify 1, the second element in the list will be returned and it will be compared against the value you specify here. So what I do here is basically I use x point 0 here. What it means is that when there is a field x, I see what is the first element in the list. However, the first two, it's the number, right? It's just a number data type. There's no list here. So when I try to check the first element inside x, there will be nothing. It will be just the first because it's not list. So I check whether it exists, and if the first element in the list x doesn't exist, this condition will be satisfied. So that's what I do. So basically here, I check whether x is number, so not list basically. So when x does not exist, I think it will apply. I mean, you can try this. So as long as x is not list, I think this condition will be satisfied. So even though, actually I'm not sure what will happen if there is no x. I mean, you can try this later. So that's the first condition. So given that x is number, given that x is not list, I use this condition. So x value should be between 10 and 20. So when these two conditions are satisfied, because I use the AND operator, so basically when the x is a number and when this condition is satisfied, it's combined by AND. In that case, that document will be returned. So the first document satisfy the first condition here, but it doesn't satisfy the second condition, so it will not be returned. And the second document here will satisfy the first condition, and also it will satisfy the second condition. So that one will be returned as a result. And then for the third one, the first condition is not satisfied because it's a list. So this part will not be satisfied and it will go to the next part. And the next part, I use AND operator and I check whether the first element in the list x exists, because I said it exists true. So if x is a list, then I use lmatch to apply this condition on each element. So in that case, the third document, the first condition will be satisfied because there is first element in the list, and then we use the lmatch to compare whether there is an element that matches this condition. So 5 doesn't match this condition, 25 also doesn't match this condition, so this third document will not be returned as a result. So that's how you can design this query. So basically, let's try this. So if I copy this, and here if I try this code and click this, oh yeah, because of this, let me delete this comment. Okay, so then this is the result that we expected. So only one document with x15 between 10 and 20 will be returned. Okay, so any questions here? So this is actually quite similar to the programming, right? So if you use Python or other programming language, and if you want to perform something like this, you will code something like this by using if and or operator. So it's exactly the same. So that's why MongoDB is a lot like programming in some sense. So that was basically all about the querying over the list. And the next one I'm going to talk about is querying embedded document. So one of the unique data type in the MongoDB is embedded document, which means that you can use document as a value inside a field in another document. So you can also query into the embedded documents using this formula. So you can specify the key in the main document, and you can specify the sub key in the embedded document, and you can specify the value you want to compare against. So you can we can do this exercise here. So I can try this code. I can copy this and put it in the MongoDB to prepare some sample data. So if I try this, then basically it will create a person collection, and inside the person collection there will be two documents. So first document has a name, embedded document data type with the first and last field inside the name, and the second document is similar. There is a name field in the main document, and name field is an embedded document with three fields: first, middle, last, like this. So the first document has a first name John, last name Doe, and the second document has a first name John, middle name Tom, last name Doe, like this. So we want to find a person whose first name is John and last name is Doe. And you may try to use this query. Then let's just see what will happen. So actually, if you see here, both of this document has a first name John and the last name Doe, like this. But when you perform this query to find the person's first name John and Doe, then you will see that only one document is returned. The second document is not returned. So let me tell you why. So when you try to do query embedded document, if you specify subkey and value like this in this format, what MongoDB does is that the MongoDB does entire match. So they are trying to find the entire embedded document match. So when you do query like this, the MongoDB will try to find this exactly same embedded document. So there should be only two fields, first and last, and the value should be like this. So if you look at our data, there is only one document that matches this exact condition. So that's why the second document is not returned in this case. So if you want to query in the embedded document without the exact match, then you can use this formula. So it's similar to index in the list. In this case, we use key.subkey, the field name in the embedded document, and we have to wrap this with a double quotation like this. Then in this case, the MongoDB will try to match a subkey instead of finding the exact subdocument. So if you, in the earlier example, if we want to find a person whose first name is John and last name is Doe, and the middle name, it doesn't matter, then in this case we can use this formula basically. So if I copy this, and put it here, then basically I'm trying to find the name field. Inside the name field, I want to look for the first field, and the first field should be John, And also I have to look at the name field, and inside the embedded document I look at the last field, and the name should be Joe. And then if I perform this, 2 documents will be returned, both as first name John, last name Doe, like this. So this is how you can do a query over embedded document. So there's one more exercise I prepared here on the query part. So let's do this very quickly. So basically, what I want to do is here. So first of all, I want to prepare some data, and I want to save those data inside the book collection. So I create the book collection, and inside the book collection, I want to insert this document. So the document has a title field, notch, and the comments field as a list of embedded document. So comments is a list data type. In this case, there are 2 comments. The first comment is embedded document with the name field Tom, rating field 5. The second is name field Jane, rating field 3, like this. And the second data is this. I add a document with the title Freakonomics and another field comments. And comments is also a list data type. And there's one element in the list, which is an embedded document with the name field Jane and rating field 4.5, like this. So basically, as a result of these 2 code, we are gonna add 2 main documents inside book collection. So if I perform this, book collection is here, and there will be 2 documents like this. So basically, I want to try to mimic and represent the situation where the book receives some review, like online review from different people, like online rating in this case. So the notch received a rating from 2 people. Tom gave 5, Jane gave 3, and Freakonomics received one rating from Jane. Rating was 4.5, like this. So given this data set, what we want to do is this. We want to retrieve those documents which received the rating higher than 4 from Jane. So let's say that Jane is a very important person, and we want to find out what are the books that Jane gave a high rating. So in this case, to solve this question, we can design query like this. So to save the time, let me type first, and let me explain to you how this works. So that's it. So we can design the query like this using LMH in this case. So what I did is this. So basically, I want to look at the comments field which contain the multiple comments from the user. And because comments list earlier, if you remember correctly, it's a list of elements. So it's the list data type. So if I want to find a rating higher than 4 from Jane, there are 2 conditions. So I want these 2 conditions to be matched against each element in the list. So I use the lm match operator in this case. And my condition is that name should be Jane and the rating should be greater than or equal to 4, like this. So copy this, and if I try here, then here's the result. So basically, yeah, there's one book which received a rating higher than 4, which is Freakonomics in this case. So this result is returned.